Okay, good morning class. Alright, so please click this link. Okay. Okay, and this is the code 36394. And the monitor, can you please check the attendance who's still not here? Okay, for those who use phone, okay, you use handphone, you can just scan the QR code here. Okay, for those who just joined the class, okay, so I will forward the link and also the code. Okay, I forward again the link. So should be 8 more students to join the class point. Because in Google Meet they got 35 students. Okay, but in the class point only 30. So means 5 more students didn't join. So please join. Okay, so we start our class now, right? So we continue, okay, for the discussion question for refraction of wave, okay? Okay, so can you please answer this question? What is the meaning by the frequency? So what is the meaning of frequency? Alice Chin Wai Hong. Okay, Kaiser got swab test. Okay, thank you. Okay. Means only Alice and Lavanya, is it? Yeah. Kaiser got swab test. You already informed me. Okay, what is the meaning of the frequency? Okay, so you already know frequency is the formula for frequency is 1 over T, right? So 1 over T. Okay, so Weizen, Jiayu, Li Yin, Xingyi, Yingwei, Natalie, Vengshen. Okay, already submit. Daniel, Wenli, Junkiat, Elvis, Yongwei, Shuyan, Ethan Lee, Wong, Jen Yep. Teacher, I cannot answer issue presented not in the slideshow. Actually, maybe because of your line. Because if like that means your friend also cannot answer. Maybe you can put your answer in the chat. Okay, so I'm still waiting for Weizen, Xingyi, Yingwei, Natalie, Daniel, Wendy, Elvis, and Ethan for the answer. Xingyi, you just put the answer in the chat. Others has same problem like Xingyi, you can put your answer in the chat. I give 30 seconds more. Then are we closed? Okay, so just put your answer in the chat, Natalie. Okay, so I will close the submission. Okay, so what's the answer? What is the meaning of frequency? Okay, so frequency is actually the number of complete oscillation in 1 second. Okay, number of complete oscillation okay in 1 second. Okay, number of complete oscillation in 1 second. So means 1 second how many complete oscillation okay that the pendulum or that the wave can make. All right, so this is the meaning of the frequency. Okay, so let's check your answer. The number of wave produced it's not wave. If you say complete, yes. Okay, so this is wrong. Okay, very good, Kenzing. The number of wave produced. Actually, you have to put the number of complete oscillation. Okay, because you know that actually the meaning of the frequency is the number of complete oscillation, not the number of or complete wave also can. Okay, complete wave. No, must be complete oscillation. All right. By number of second, the rate of no. That one is the rate per second of a wave, no. The number of wave produced in 1 second, no. Okay, so have to put the number of complete oscillation. Number of oscillation, yes, good. The number of complete is good. Occurrence of repeating event per unit of time, alright. The number of second. Okay, very good. The rate, no. Okay, the number of complete oscillation. Right, no. Oh, this one is correct. The number of wave, no. Number of complete oscillation. Alright. So for this one, you just put B is what, B1 is what, B2 is what, B3 is what, and B4 is what. What is the answer? Okay, so for those who just joined the class, this is the link. So you can join using the link I give and also the code. Okay, so you have to compare the depth of the water in region X and Y, right? And then the wavelength, okay? And then the relationship between the depth of the water and also the length, the wavelength, right? The wavelength of the wave. And also what is the wave phenomenon involved? So how you want to know the depth of the water? You can just refer the wavelength of X and Y, right? So you know when the higher, the deeper the water, right? The deeper the water, the higher the wavelength. Okay, you can use the symbol to answer the comparison questions. Okay, you can use the symbol, this one, or like this, to answer for question number B1 and B2. Okay, I give you 1 more minute to answer for this question. Okay, Zinyi, water region X is deeper. Wavelength, the deeper, the longer the wavelength, and refraction. Okay, very good, Zinyi. You want to log out from the class point and then you enter again, log in again. I will remove your name. Is it okay, Zinni? Zinni. Wait, I find your name first. Zinni. Zinni, your name is not here. Yeah, your name is not here. Yeah, okay. Sorry. Right. Okay, so I stop sharing. Okay, close. Alright, so let's discuss the answer. So here it said observe diagram 6.1 and 6.2. So it asks you to compare the depth of the water in region X and region Y. Okay, so here the region X, you can see the wavelength of region X is higher than the wavelength of the region Y. Okay, so means X is deeper than Y. Okay, so you can just put here depth of water, okay, for X is higher than Y. Okay, the next one you have to compare the wavelength. So the wavelength of X is higher than Y. Wavelength of X is higher than Y. Okay, the next part it asks you to relate the depth of water, okay, to the wavelength of the wave. So here I already said just now, right? The deeper the water, okay, the higher the wavelength, or the higher the depth of the water, the higher the wavelength of the wave. Okay, so this one you have to put in full sentence, or you just can put directly proportional. Okay. So the higher the depth of water, the higher the wavelength, or you can put directly proportional. Both also can. Okay. Okay, so name the wave phenomenon involved. So this one we call it as a refraction. Okay, so refraction. Okay, so let's check your answer. Greater than X, the deeper refraction. Okay, very good. Water in region X is shallow. X is shallow. No, because the wavelength is higher than Y, right? So mean that X must be deeper than Y. Okay. Okay, very good. Reflection, no, this one is refraction. Okay, so if there is a change of depth of water, okay, that one is actually the refraction, right? So not reflection. Deeper. No, the question asks you the phenomenon, not the type of wave. If the question asks the type of wave, then you can say transverse or longitudinal. Okay, so they ask you the wave phenomenon, there are only 4 answers. Okay, if they ask you for the wave phenomenon, there are only 4 answers, whether it's reflection, refraction, okay, diffraction, or Another one is interference. Okay, this is for the answer for the question. If they ask you what type of wave, so the answer should be transverse or longitudinal. Okay, so this one is wrong. The deeper the water, yes. Dispersion, no. All right, very good. No, this is not asking you about the type of wave. Okay, the bigger the wavelength, the deeper. Okay. X is equal then what? Is equal y. How come x is equal to y? You can see x is the wavelength is higher than y. Okay. The depth of the region X is more dense. No, it's not dense. Okay. Wrong. No. Okay, for this one, actually you have to relate, right? So for relate should be the higher, the higher, the higher, the higher, or the higher, the lower, or you can just put directly proportional or inversely proportional. Okay, that is the how you want to answer the relationship question. Okay, all right. No, no, this is not reflection. Okay. Decrease when going to water. Yes, refraction of wave. X is higher than Y. No, the deeper the close, the deeper the depth of the water, the distance. Okay, it will be more distance. Okay, from each other, the wavelength. Okay, refraction. Yes. Okay. Okay, very good. Okay, bigger than what? You have to mention what is bigger than what wavelength. Okay, so the last one before we go to the diffraction. So this one you have to explain why the wavefront of seawater will follow the shape of the shore when it approaches the shore. So why is follow the shape of the shore? Okay, so this is actually you have to explain why does the refraction of wave occur. Okay, like the example for the light, right? So for the light is actually because of the difference of density. Okay, so let's say light travel from the denser to the less dense part. Okay, so the refraction will occur, right? And also for the sound also, okay, refraction of sound also it depends on the density. It happens because of the density. Okay, the density of the hot air is lower than the density of the cold air. So when the sound travel from the low dense to the high dense. Okay, high dense. So it will be refracted, right, towards the normal line. So that one for the sound and for the sound and also for the light. Okay, it happened because of the different density, okay, of the medium. Okay, but for the water wave, okay, it actually depends on what? Okay, I give 1 more minutes. Okay, so we close the submission. All right, so let's discuss the answer. So what happened actually, okay, when the seawater, it approached the beach. So what is the difference? Of course, the first one is the depth of the water, right? So the depth of the water is decreasing. The depth of water decreasing. Okay, then another one, what happened? When the depth of the water, what happened to the wavelength? Okay, so the wavelength also will be decreased. The wavelength of water will decrease. Okay, so what happened? What is the phenomenon occur here? So this one is actually refraction. So refraction occur. Okay, so that's the answer. So 3 marks. So you can see for each point that I gave, there is 1 mark here. So if you want to answer the question like this, you have to put in the point form. So it's easy for you to know that actually 1 point is actually equals to 1 mark. But sometimes, all right, one sentence also they can give you 2 marks. Okay, but usually for 1 point, 1 mark. Okay, so please answer in the point form like this. Okay, so we move on to the next wave phenomenon, that is a diffraction. Okay. All right. So I will give you a new code. Okay. I will give you a new code. Right. So maybe you can load up from the class point. Okay. Then we use this code. Okay. So the code is 71280. Okay. And the website is this one. Okay. We wait for another 6 more to join. Okay, so we start the class. Okay, so diffraction of wave. So remember, okay, there are 4 types of wave phenomenon. Okay, so the first one we already learned reflection. Okay, and just now we learned refraction. Okay, and this one is a diffraction, and the last one is the interference. Okay, so reflection is actually after the reflection. Okay, after the reflection, the speed, the frequency, and also the wavelength is same. Okay, is same. Okay, only the direction of propagation change. Okay, so that's what we learn. Okay, for the reflection of wave. Okay, for the refraction of wave, okay. So the speed, okay, the wavelength, okay, change, okay, and frequency is same, okay. While the direction of propagation also change. Okay. Okay, so this is what we learn. Okay, so you have to remember for the characteristic for refraction and for the refraction. So now we see for the diffraction. Okay, so what is actually diffraction? Okay, so diagram below shows 2 walls which are built near the shore. So compare the wave pattern with before and after passing the gap between the 2 walls. So what is the function of the wall here? So you can see this is the wave, okay, the seawater wave, okay, then it enter the slit here, okay, enter a slit here, the opening, okay, a small opening here, then you can see the wavelength is become circle like this, okay, so it becomes circle like this. All right, so what is the difference? Okay, so different is actually the shape of wavelength, right, and another thing is actually the amplitude. So what is the function of the wall here? Okay, right, so this is the another example, okay, of the diffraction. So let's see the video here. So you can see there is the opening here, okay, the wall opening here. So the water wave, okay, come through the opening here. Then you can see the wavelength of the wavelength of the water, okay, the shape of it become like a semicircle like that. Okay, so this is actually the example of the diffraction. So why they have to put the wall like that? So actually you have to know when the water wave enter the small slit, okay, then the wave will be spread out. Okay, so the wave will be spread out. So when the wave is spread out means the energy also will be spread out. So at the part here, at this part, okay, the amplitude will be lower. Okay, the energy will be lower. So means the water will be calm. Okay, so that's why they put the opening here. Okay, so what does it mean by the diffraction of wave? Okay, so diffraction of wave is phenomenon in which waves spread out, okay, or bend as they pass through a gap or around a small obstacle. Okay, so just now I already said the wave, okay, when it pass through it pass through the wall here, okay, the opening here, the slit here, so you can see the wavelength, okay, or the energy here will be spread out. Okay, the wave will be spread out. So you can see here at this part, the water is more calm, right? If you compare at the A part, okay, at the P part, you can see the wavelength, okay, the water is more calm. Okay, because the energy of the wavelength is spread out, okay, when you pass through the slit. Okay, so the meaning of the diffraction is which waves spread out as they pass through a gap or round a small obstacle. So that is the meaning of the diffraction. Okay, so let's see the video. So you can see the difference, right? Okay, so you can see the wavelength pass through the slit. So this is the small slit and this one is the bigger slit. Okay, so when it pass through the small slit, all right, the wavelength will become circular. Okay, but when you pass through the slit is bigger. Okay, the slit is bigger. You can see the wavelength here. Okay, it become like this. It's less circular. All right. So means here we can say, right, the smaller the gap, okay, the more circular the wavelength. Okay, the more circular the wavelength will be produced. Okay. All right. So we move on to the next slide. Okay. So this video. So this is the obstacle. So what happened? So you have to know how to draw the wave. Okay. So that's the video. So what actually we can make a conclusion there. Okay, so what is the factor that affecting the diffraction? Okay, so the first one is the wavelength. Okay, the first one is the wavelength. So the bigger the wavelength or the higher the wavelength, the effect of the diffraction will be higher. Okay, will be higher. So means the wavelength will become more circular. Okay, they'll become more circular. Okay, and then the second one, okay, so what is the effect? The factor, the actually the gap of the size of the gap, okay, or the size of the slit. Okay, if the size of the slit is smaller, okay, so the smaller the size of the slit, the smaller the size of the slit, okay, the effect of diffraction will become higher. The effect of the diffraction will become higher. Okay, so that's the two factor that affecting the effect of diffraction. So means the amplitude will become more lower. Okay, so means the energy of the wavelength will become lower. So the water will become more calm. Okay, so there are two factors. The first one is the wavelength and the second one is the size of slit. Okay, the first one for the wavelength, if the wavelength is higher, you can see the effect of diffraction also will become higher. Okay, and then the second one is the size of the slit. Okay, the smaller the size of the slit, okay, the effect of diffraction will be higher. So you come, the wavelength here will become more circular. Okay, so this is actually the video, okay, by using the ripple tech. Okay, you can see this using the smaller slit. So what you can see here there is a circular wave produced. Okay, if you use the smaller slit. Right? Okay. So now, okay. So this is how you want to draw, okay, for the diffracted wave. So let's say this is the white gap, right? So, okay, I teach you how to draw. So let's say this is the large gap, okay, and this is the wavelength. So what you need to do first, okay, you have to make a line like this. Okay, you have to make a line like this. Okay, and then since this one, the gap is very large, right? So means it cannot form the circular wave. So what you will do, okay, you just make the plane wave, okay, like this. But remember, the wavelength should be same before and after the diffraction. Okay, so before the diffraction and also after the diffraction, the wavelength should be same. Okay, should be same. Okay, like this. All right, and then another part, let's say the gap is narrow. Okay, the size of slit is small. Okay, so let's say like this. Okay, so what you have to do, you have to draw a line like this. Okay, so this one is actually to show the wave, okay, spreading. Okay, so and then this one you make a circle. Because this one is a smaller slit. Okay, you make a circle. But make sure the wavelength before the diffraction and after the diffraction must be same. Okay, so this is how you want to draw for the narrow gap and the wide gap. So what happens if for the obstacle? Okay, let's say you have a barrier or obstacle here. So for the small obstacle, okay, what you have to do, let's say this is the wavelength, right? Okay, there is a small obstacle here. So you have to make line like this. Okay, you have to make line like this. Okay, and then the wavelength should be at this part. Okay, so make sure the wavelength before and after the diffraction must be same. Okay, so then be like this. Okay, and let's say for the when the obstacle is bigger. Okay, it's bigger. So let's say like this. So same ways. Okay, you make a line like this. Okay, and then you draw like this. But make sure again the wavelength before and after the diffraction is same. Right? So that's how you want to draw for the wide gap, narrow gap, okay, and small barrier or large barrier. Okay. The important part is before and after the diffraction, the wavelength must be same. Okay. Okay, so we have to compare the wavelength. Okay, we have to compare the wavelength of the wave before and after passing the gap. So just now I already told you the wavelength before and after it passing the gap. Okay, the wavelength must be same. Okay, the wavelength must be same. Okay, is equal before and after. Okay, what you can say about the direction of the wave after passing through the gap? So you can see it's spread out. Okay, so that's why they made a gap there. So the energy from the water wave will be spread out. Okay, so it will not be converged into one point. So when the energy be spread out means the energy will be lowered. Okay, so the amplitude will be lower and the water will be more calm there. Okay, so it will be spread out. Right, so for now, I want you try to draw, okay, for the small gap and also for the large gap. Okay, so try to draw. Remember, before and after the diffraction, okay, the wavelength must be same. Okay, so some of you already give the answer. Okay, I give 1 more minute for you to draw. Okay. Okay. Alright, so let's check your answer. Okay, so let's try to draw. Okay, for this one, this is a small gap, right? So for the small gap, you can just draw, okay, circular wave, right? But make sure the wavelength is same. Okay, wait for a moment. Okay, so you can just estimate, okay, just to make sure that the wavelength is same like that. Okay, so this is the wavelength after passing through the small gap. Okay, what happens if the gap is bigger? Okay, so here you have to draw the line like this. Okay. Okay, but the wavelength must be same before and after. Like that. Okay, so let's check your answer. Okay, very good, Jen Hong. Okay. Joey, make sure you have this line. Okay. Okay, should start from here. Okay. And the line should be inside of the area. Okay, this area cannot go more than that. Okay, all right. Okay, this also same, but maybe because you use a mouse, right, to draw, so I understand. Okay. Okay, just the wavelength. Okay, so just be careful about the wavelength. Wavelength must be same before and after. Okay. This one, the line. Okay, make sure you have a line here. So whatever you draw, it must be in the area. Okay. Always this one should be circular. Okay. This one because it's a narrow slit. Okay. This one the gap is bigger, then it will be like this. Okay. For the smaller slit, it should be semicolor. Semicolor wave. Okay, so this one, okay, very good, Verilog. Should be spread out more. Okay. Okay, very good. Okay, this one should be like this. Okay, so the line should be inside of the area. Okay, Vincent. Okay, very good, Kelly. All right, Yongwei. Okay, very good. This one. Okay, so inside there is no wavelength. You start from after the gap. Okay, make sure you start after the gap. This one cannot be circular because the gap is bigger, right? So it should be like this. Okay, this is wrong. Okay, very good, Jaen. All right. Okay, so it's starting from here after the gap. Okay, after the gap, not before. Okay, so this one also should be have the line here, right? Okay, and this one, remember, the line should be inside the area, not until. Okay, this one it should be circle, right? Semicolon. All right. So the next part, okay, if the wavelength passing through the obstacle, okay, or the barrier. So try to draw for this one. This one is a small barrier. This one is a large barrier. Remember, you have to have the line, okay? So you know where is the part that you need to draw the wavelength, okay? And where is the part that you should leave it empty. Okay, I give you 1 more minute. Okay, 50 more seconds. Then are we close? Okay. Alright, so so I want to draw the wavelength, right? When pass through the barrier. Okay, so the first one, it should be like this, right? Okay. Wait for a moment. My laptop is hanging. Wait for a moment. Aish. Okay. Oh, right. Okay, then after that, you draw a line like this. Okay, but the wavelength must be same between before and after the diffraction. Okay, so this one also like this. Okay, so that's the answer. So let's check your answer. Okay, good. Um, should be like this. Okay, should be like this. Okay, okay, good. Okay. Sorry, my mistake. Before I teach you like this, right? Actually, it's like this. Okay, this one is for the gap. Okay, for the barrier, it should be like this, the line. Okay, sorry, my mistake. Only for the opening or for the slit, it will be like this. For the gap, it should be like this. Okay. Mm, it should be start from the gap. Okay, like this. Okay, good. Okay. Okay. No. Semicolor is only for the small gap. Okay. For the barrier, they will not form the semicolor. Okay, so state the changes to the incident wave that occur after passing the gap. So frequency is same, wavelength is same, okay, the speed also same, the direction is spread out, okay, and the amplitude is decreased, or sometimes they use energy. Okay, so this is the difference between before and after the diffraction of wave. So if you can see here, this one is actually similar to the reflection of wave. Reflection also speed, frequency, and also the wavelength is not changed, right? Only the direction of the propagation, right? So it's almost same like the reflection. Okay, but the reflection they didn't mention about the amplitude, but for the diffraction they mention about the amplitude of energy. Okay, so mean this one for the diffraction is almost same. Okay, the characteristic is almost same as the reflection, uh, but the amplitude, right? But the amplitude of the energy will be decreased. Okay, after the diffraction. And another one, the direction is spread out. Okay, it will be spread out. The energy will be spread out. Okay, so that is the difference. Okay, why the amplitude of the diffracted wave decrease? Okay, so the diffracted wave is spread out, okay, to wider area. Okay, so the energy of the wave will be reduced, so the amplitude will be decreased. So now the wave will be spread out. Okay, so means all the energy also will be spread out in the larger area. So when the energy will be spread out, means the energy will become decreased. Okay, so that's why at that part the water is more calm. Alright, the next one is study the factor which influence the diffraction of water wave. So this one actually we already discussed. Okay, so for the small gap, you can see the wavelength is circular wave. Okay, and for the bigger gap, the plane and bend at the edge. So you can see that at the edge here, it bend, right? So here the diffraction will become more obvious. Okay, if we compare with the bigger gap. Okay, how about the small barrier and the bigger barrier? So you can see the small space behind the bigger barrier here, okay, is smaller, okay, at this part, okay. The small space behind the barrier is smaller. Here, if you use the bigger barrier, the small space, okay, behind the barrier is larger, okay. So that is a big space of the, big space, okay, behind the barrier, and this one only small space. So here we can see the diffraction is obvious, while this one the diffraction less obvious. Okay, so means the smaller the gap, okay, the diffraction will become more obvious. So what is the relationship between the shapes of the diffracted wave with the size of the gap? So here we can say the smaller the gap, the more circular the diffracted wave. Okay, I already told you, right? If the gap is smaller, means the wave is more circular and the effect of the diffraction is higher. Okay. And describe the pattern of the wave with different wavelength after passing through the gap of same size. So let's say we use a same size gap here, but we use a different wavelength. So this is the small wavelength and this is the bigger wavelength. So here there will be plane and bend at the edge, okay, while here the wave will become more circular. So we can conclude here, okay, the higher the wavelength, okay, the more obvious the effect of the diffraction. Okay, so what is the relationship between the shape of the diffracted wave with the size of wavelength? So the longer the wavelength, the more circular the diffracted wave. Okay, so state two factors that make diffraction more obvious. Okay, so the first one is the small gap. Okay, so the small gap, the smaller the gap, the higher the effect of diffraction. While the wavelength, the higher the wavelength, the higher the effect of diffraction. Okay, so here is actually the diagram, okay, to see the effect of diffraction of wave. So let's say if you fix the wavelength, okay, so the wavelength is same, right, and we just change the gap. Okay, so for the wide gap, and this one is for the small gap, right? So for the wide gap, the diffraction will be less obvious. Okay, why if the small gap, okay, the diffraction obvious, okay, means you can see the effect of diffraction, the wave become more circular. Okay, so this one, if we fix the wavelength before and after, we use the same wavelength. Okay, and this one, let's say we fix the size of slit, okay, but we change the wavelength. All right, so this is the wavelength is lower, okay, the short wavelength. So when the short wavelength, you can see the diffraction is less obvious. While if you use the high wavelength or long wavelength, you can see the effect of the diffraction is obvious. Okay, so what you have to remember here, okay, effect of diffraction, okay, factor that affect the diffraction is 2. The first one is the size of slit. Okay, so smaller size, okay, the higher the effect of diffraction. Okay, so about the wavelength, okay, longer wavelength, okay, longer wavelength, okay, the effect of diffraction more obvious. Okay, so that's the two factors that affect the diffraction of wave. Okay, so we already finished about the diffraction of water. Okay, so now we go for the diffraction of sound wave. Okay, so the audible sound wave have wavelength in the range of 1.5 cm to 15 cm. So light wave have wavelength in the range of 4 until 7 times 10 power of negative 7 meter. So a radio is placed nearby corner of a wall. So the radio is turned on, right? So the radio is turned on. So what will happen? So we have to compare the wavelength between the sound wave and the light wave. So here already mentioned, all right, the sound wave have wavelength 1.5 cm to 15 cm. Okay, but the light wavelength only like 5 until 7 times 10 power of negative 7. So mean the wavelength of sound wave is higher. Okay, so can you see the radio? So of course you cannot see the radio. So what inference can you make, okay, about the diffraction of light wave? Okay, so light difficult to be diffracted because of the smaller wavelength. Okay, remember just now we said that wavelength is the factor of affecting the diffraction. So the higher the wavelength, the higher the effect of diffraction. But you can see here the light, they only have like 5 until 7 times 10 power of negative 7. That is too small, right? So means they cannot diffract too well. Okay, so the diffraction will be less obvious. So that's why, okay, we cannot, the light is difficult to be diffracted if we compare to the sound wave. Okay, so can you hear the sound of the radio? So what inference you can make about the diffraction of sound wave? So of course you can still hear the sound, okay, because the sound can be diffracted. Why? Because the wavelength is bigger. Okay, but why we cannot diffract the light wave? Okay, because the light wave have the very small, okay, very small wavelength. So it's not easy for the light to be diffracted. Okay, now is it relate between the wavelength with the effect of diffraction in order to explain why we can hear the sound of radio placed nearby a corner of a wall but we cannot see the radio. Okay, so sound waves are more easily diffracted because its wavelength is longer than the wavelength of light. Okay, so that's the reason, because of the wavelength. Okay, so the next part, okay, to study the diffraction of light wave. So just now what we learned is only for the water wave. Okay, we draw the water wave. How does the shape, okay, before and after it being diffract? When you pass through the small gap, when you pass through the wider slit, okay, and what happened when you pass through the barrier, the small barrier, the large barrier. So how we draw? Okay, that one is all for the water wave. Okay, so next part is how does the light wave being diffract. Okay, so the first one, you have to direct the laser light ray, okay, through the single slit. Okay, so this is the slit here. Okay, so it's very small. Okay, and then you have to observe the pattern form on the screen and draw the pattern. Okay, then you have to repeat by using the single narrow slit and also a small pinhole. Okay, so this is the experiment.
This is a demonstration of single slit diffraction. When a laser beam, this is putting my hand in the beam.
So that's the laser.
This laser beam is incident on this circular dial that allows me to dial in the width of a slit through which the laser beam passes. So it's passing through this slit of various widths that I'll show you, and then having passed through the vertical slit, produces a pattern on the screen here. So the width, and what you see in this pattern is a central bright spot and then dimmer spots to either side. This is called the M equals 0 maximum, the M equals 1 on either side of that, M equals 2, etc. With
okay, what I want you to see only the size of the fringes here, okay, and what's the color, whether it's bright or dark.
0.02 millimeters. If we move to
so it changed the slit now, 0.04. Okay, just now is 0.02, now it changed to 0.04. Okay, so you can see just now it's very wider, right? The fringes, right? So now it becomes smaller. So this one is 0.08. Okay, mean it increased the size of the slit.
0.16 pattern, very tight. We can also do the same with circular apertures.
Okay, so this one is from the hole, okay, by using one hole.
Through which the laser beam pointed. This is a circular aperture. The laser beam is incident on a hole and blocked from passing outside the hole and only goes through that hole. And what you see here is a pattern with a central bright spot in the middle, but then rings around it that are reminiscent of the dots that appeared in the single slit pattern.
Okay, so it formed like a ring here and the white spot, okay, in the center.
A circular aperture. It's important in resolving stars. Has relevance to the radial criterion, where at a central dot that to resolve two stars, you have to take into account this diffraction pattern. This is a smaller aperture. The earlier aperture was 0.2 millimeters, and this is 0.4.
Okay, so 0.2 and this one is 0.4.
Very small.
Okay, so you can see the line here very, very small, right? Very small diffraction.
Diffraction pattern from single slits and circular aperture.
Okay. All right. Okay, single slit diffraction. This one by shining a laser. Okay, this one we use a red laser. Okay, just now we use the green one, right? Okay, so it changed the size of the slit. Okay, so when you increase the size of the slit here, okay, so when you increase, what will happen? You can see the fringes, okay, it become more smaller. Okay, you can see the size here, okay, it become more smaller. So it's just like it's like inversely proportional, right? So when you increase this you increase the size of the slit, okay, when you decrease the size of the slit here, okay, so let's see just now. So when you increase the size of the slit, you can see here the line here, okay, the size of the beam here become smaller, right? It becomes smaller. So it's like the inversely proportional relationship. Okay, so now it increased the it decreased the size of the slit. So when it decreased the size of the slit, right, you can see here the the size of the beam here become bigger, right? So it's just like the inversely proportional relationship. Okay, now they use a small hole. Okay, so they use the yellow laser. Okay, so this is the size of the diffraction. You can see there is a bright spot, okay, on the center of it, right? So that's the video, okay, for the light diffraction. Okay, so narrow slit, okay, so the narrow slit, all right, will produce the large, right, the large beam here. Okay, while the wider slit, they will produce the small. Okay, so it's like I already told you just now, the relationship is like inversely proportional. So when the size of slit is increased, okay, the fringes, okay, will become the size, okay, the size of the fringes will become smaller, right? So we already saw the video just now. Okay, it's brighter in the middle. Okay, so this is the, okay, so 0.02, you can see the fringes is bigger, and this one, when you increase to 0.04, it become smaller. So you increase again the size slit, it become more smaller. Then 0.16 become more smaller. Okay. So question number 4. So it says here, experiment is repeated by using a pinhole camera as shown in diagram 1.4.6. So it said what happened to the light as it passes through the pinhole. So of course the light will be diffracted. So here anything that comes, let's say the light comes through from the hole, okay, so of course the light will be diffracted. Okay, pass through the hole, of course the light will be diffracted. Okay, and then the next part is to study the application of diffraction of water, light, and sound. So just now we already see the diffraction of water. Okay, we already know what happened. Okay, how does the wavelength, okay, look like after it being diffract. Okay, and light also we already see there is a large beam, okay, in the middle of the screen there. Okay, large fringes, small fringes, right? And you have to know what is the effect. Okay, how does it affect? It means the size of the slit. So the bigger the size of the slit, okay, the lower the effect. It means the fringes in the middle here will become smaller, right? And for the sound wave, you already know for the sound wave, okay, it can be diffracted because of the higher wavelength, okay, if you compare with the light wave. Okay, light wave, they have a smaller wavelength, so it's hard for the sound wave, it's hard for the light wave to be diffracted. Okay, why the sound wave have a bigger wavelength, so mean it will more easy for it to be diffracted. So that's why even let's say you put the radio, okay, at the corner and you stand, okay, behind the wall, you can still hear the sound. Okay, so we have to know what's the application. So what's the function of the diffraction, okay, in our daily life. Okay, so the first one we use in the water wave. Okay, so a pair of barriers is built to protect housing area near a beach. So they will put the barrier here. Okay, so this one is actually to reduce, okay, to reduce the effect, okay, of the to reduce the amplitude. Okay, so here the water will become more calm. Okay, so they put like the wall, okay, and it has a small slit. So when the water wave comes through the slit here, so the water will become more calm. Okay, so the energy here will become decreased. Okay, so the amplitude is decreased. So that's the reason. So by relating the size of the wave with the energy, explain how the erosion effect of the beach around the housing area can be reduced by the barriers. Okay, so here you build the barrier with the small opening so that the diffraction can occur. Okay, so actually the diffraction gives a good effect. Okay, because it decrease the amplitude. So means when the energy is decreased, okay, so the wave also, okay, the energy of the wave also will be decreased. Okay, so the build barrier with the small opening so that diffraction can occur. So the energy of the wave is spread out to larger area after passing the gap and will be reduced. Okay, so the amplitude of the amplitude of the wave will be decreased. So this is how you explain, right? So the diffraction of water wave produce a calm water of water region suitable for docking of ships, okay, and water, okay, recreational activities. So here, if you have the wall here, so the water here will become more calm, okay, because after the water wave pass through the slit here, the energy will be decreased. So I said just now, okay, the water here at this part will become more calm. So it's easy, is suitable for the ships to be docked and also for the water recreational activities. Okay, can go to swim. Okay, at this part. Alright, so an audio frequency generator connected to a speaker and placed near the corner of a wall. So three students A, B, and C, okay, are standing around the next corner. So the generator and the speaker can produce sound at the same speed but different frequency. Alright, so when the high frequency sound is generated, only student C can hear the sound clearly. Okay, when the high frequency sound is generated, alright, so only the C can hear. Okay, but when the frequency of sound, when the low frequency sound is generated, all the three students can hear. So why is that? Right? So actually it's because of the frequency is inversely proportional to wavelength. So how does we know? This one is actually derived from this formula. Okay, so when the frequency is higher, the wavelength is lower. Okay, and you know the effect of diffraction, right? There are two factors that affecting. The first one is the wavelength, and the second one is the size of slit. So for this one is actually it depend on the wavelength. So when the frequency is higher, right, the wavelength will be lower. Okay, and we know that the higher the wavelength, the higher the effect of the diffraction. So this one, when the frequency is higher, the wavelength is lower. So mean of course there will be less effect of the diffraction. So that's why only C can hear. Okay, but when it's decrease the frequency, okay, so when you decrease the frequency, what will happen to the wavelength? The wavelength will become higher. So mean if the wavelength become higher, we know that the higher the wavelength, the higher the effect of the diffractions. So means will be more sound of wave will be diffracted. So that's why all the three students can hear the sound, okay, when the frequency is lower. Right, so the frequency is inversely proportional to wavelength. So high frequency means the wavelength is shorter, so difficult to diffract, only C can hear clearly. Right, and when the sound easily diffracted when long wavelength, so all three students hear clearly. So remember you have to use the formula. Okay, so when you say frequency is higher, then you try to use this formula to find the relationship between the frequency and the wavelength. So means when they use the high frequency, all right, the wavelength will be lower. And you already know, right, wavelength is the one factor that affecting the effect of diffraction. If you use the higher wavelength, means the effect of diffraction is higher. Okay, so that's mean there will be more people that can hear the sound. Okay. Okay, the next example is owls are able to communicate across long distance in the forest because they have the long wavelength hoods. Okay, so explain. Okay, the sound of the owls will diffract through the space, okay, between trees in the forest. So the longer the wavelength of the hoods, also easier to be diffracted. Okay, so this is the use of the diffraction, okay, for animals. Okay, and the next part is for elephants. So infrasonic wave produced by elephant have long wavelength to facilitate long distance communication between the elephants. Okay, So this is another also. This one is the diffraction of light wave can produce holograms, okay, which are used as safety features on bank cards such as debit and credit card. Okay, so we still, right, so already 12, right? So we continue, okay, for answer this question on next Tuesday. So next Thursday, okay, as usual, you will present your project. So I hope you can ready. Okay, we continue from that. Okay, so thank you class. Okay, so see you on Thursday. Right, take care. And for those who still didn't submit the the homework, please submit your homework. Okay, so thank you. Okay, bye. Welcome.